Right, this is 11, section 11.1 about the ellipse. So first, the definition of the ellipse is: an ellipse is a set of all points on a plane whose distances from two fixed points in the plane have a constant sum. Yeah, if you look at the picture of the ellipse, that means that point and the two fixed points are right there. That plus that, right, the sum of the two distances is the same for any point. Okay, all right. The fixed points are the foci. The line through the foci is the focal axis. The midpoint in between F1 and F2 is the center. That's right there. Center. In this case, it'll be 0, 0. And the point where the ellipse intersects its axis is are the vertices of the ellipse. So the vertices are on the length, on the longer edges of the ellipse, right? So that it's longer horizontally, so the vertices are here. And then we'll find out that if it's flipped around and it's longer vertically, then the vertices are up and down. Okay, so it just follows the figure. All right, so so we want to look at the sum of the two distances, and note that this says that it's 2a. How do we know that? Well, we know that for this reason. If I look at this point, the sum of the distances to the foci, that's that distance to one focus, and then this distance to the other focus. But that smaller distance is the same as this smaller distance over here. So I can say it's the big distance from this point over here. That's the distance to one focus, plus this distance to the other focus is a plus a. So it's 2a. That's how we know it's 2a. Okay, and I also want to look at this: a squared minus c squared equals b squared, or we can think of that as a squared equals b squared plus c squared. All right, there's b, there's c, the length, the distance to the focus, and there's a, the length to the vertex. Okay, so how do we know that that's true? Well, if we look at this point up here at 0b, the distances have to add to the foci have to add up to 2a. They're the same distance, so therefore it's each distance is a, right? This is b, this is c, so therefore b squared plus c squared equals a squared. Okay. All right. So and the rest of it is just using the distance formula to show that the equation is such: x squared over a squared plus y squared over b squared equals 1. All right, so that's our standard equation: x squared over a squared plus y squared over b squared equals 1. The focal axis, remember we said, was the x-axis. The foci are c from the center to the left and to the right. The vertices are a to the left and to the right of center, a distance a. And the major axis length, the major axis is the one that's lengthwise from end to end of the vertex, and then the other one's a minor. You'll also see semi-major, which means from the center to the edge, and semi-minor. All right, and then the Pythagorean relationship that we just discussed: a squared equals c squared plus b squared. Oh, what happens if we flip this along the line y equals x and just flip it around? Well, it becomes the same ellipse, but standing up now. So the length, it's longer vertically, right? This one's longer horizontally. That one will be longer vertically. And if you remember, when you go across the line y equals x, that's inverses, which means you're switching your x and y, right? All you're doing is switching your x and y values. And so that happens here also, right? So when it's a vertex standing up with center 0, 0, its equation is going to be y squared over a squared plus x squared over b squared equals 1. All right, so now it's hard to remember that. So here's what you want to know. The a is a bigger number, and it goes under the longer dimension. So if the x is the longer dimension, then the a will be under the x, a squared, and a squared will always be the bigger amount of a squared and b squared. And if it's vertically longer, then it's y squared over a squared. Okay, so the bigger number will be under the y squared. All right, and everything switches around, right? So that switches to that, right? They just switch place. Okay. All right. Again, your foci are distance c from the center, but in this case it'll be vertically for both the focus and the vertex, or vertices and foci. All right, let's take a look at an example. So we're gonna graph this ellipse, identify center, vertices, minor axes, endpoints, and foci. And anytime you're doing this, it really helps to look at the picture first. It'll be easy to see because, remember I just talked about the a squared is, the bigger number is a squared, it's under the bigger dimension, right? So here, because the bigger number is under the x, then this is horizontally longer, okay? And we also know from the center, which will be 0, 0, how far to go to the left and to the right? 3, because this is a squared. So it's 3 to the left. These are the vertices, right? There they are. And then the other dimension, vertically, it's 2 up and 2 down, right? Because that's b squared. So it's 2 up and 2 down. And I can draw a little picture already. This is my ellipse, not a very pretty ellipse, I know. Okay, so kind of like so. There we go. All right, now the foci are going to be this way, to the left and to the right of center. And so that's, remember, a squared equals b squared plus c squared, right? So c squared equals a squared minus b squared. Yeah? So this will be c squared equals 9 minus 4, which equals 5. So c is plus or minus square root of 5. All right, so from 0, 0, plus or minus square root of 5 to the sides. Okay, and square root of 5 is a little bit past 2, so your foci are going to be somewhere around there. Okay, and we can have the coordinates now. Okay, so the center, we can now list all these. The center is 0, 0. Vertices are 2, right? Negative 3, 0 and positive 3, 0. The minor axis endpoints, and those are given by b, right? So it's from 0 up 2 and down 2, so it's 0, 2, and 0, negative 2. 0, 2, 0, negative 2. And the foci. And there's 2, right? To the left, negative square root of 2, 0. Negative root 2, 0. And to the right, positive root 2, 0. There we go. We got everything down. Okay. Let's look at what happens when the center moves. It just moves. You just shift, right? Same story. Right? It shifts to hk, and it's written x minus h squared plus y minus k squared. All right. The a is still under, the bigger number is still a squared, and it's still under the bigger dimension. Okay? Everything else remains the same, right? Where your focal axis is just through the center, lengthwise. So if it's horizontally longer, then it's y equals. If it's vertically longer, then it's x equals. Okay. Your foci are C to the left and right of center, or up and down from center. Your vertices are A to the left and right of center, or A up and down from center. All right, and everything else is the same. All right, so let's graph one of these. Let's do one example. So we're gonna graph this, identify center, vertices, minor axes, endpoints, and foci. Same thing. Okay, so the 25 is larger, it's under the x, so this is horizontally longer. The center is x minus negative 1. This is x minus negative 1, so that's our h, and our k is 2. So at negative 1, 2 is the center. All right, from the center, a is 5, so to the right 5. That's one vertex. To the left 5. That's another vertex. Minor axis is up 3 and down 3. There it is. I'm going to go ahead and fill in the picture. It doesn't have to be a very pretty picture, but you don't want to do a sloppy job either, right? Something like that. like so. Okay, there's my parabola. All right, so now my foci are, remember, c squared equals, a squared equals c squared plus b squared, so this is a squared minus b squared. So c squared is 25 minus 9, which is 16. So c is plus or minus 4. That's 4 plus or minus 4 from center, right? So it'll be from center here and there. So now I have everything I need. So the center is at negative 1, 2. All right. Vertices are at negative 6, 2, comma, 4, 2. I'm just listing the points. Okay. Minor x's endpoints. Endpoints are these: negative 1, 5, negative 1, negative 1. And finally, foci, negative 5, 2, and 3, 2. All right, and you're going to do the next one we'll do in class. All right, and I'm going to stop this part here and continue. Let me see, or do I want to continue? Yeah, we'll continue on this next page on the next video.